Okay, so we need to do some a video on more permutations and about permutations and combinations. So let me put the title up there. Here we go. More on permutations and combinations. Okay, so the first problem I want to do, as far as that's concerned, is show you a particular type of problem involving really it's an offshoot of permutations with its own formula. Let me give you the problem. Let's say you have nine spots in a store, 9 spots to display fruit. There's not much room but you have nine spots. Okay, and the rules of the game here is that the same fruit. We're going to talk about how many different orders this can happen. So hold on. So the same fruit is if it's the same exact fruit, then it is not a distinct order. The same fruit next to each other. If you got the same fruit, right? If you put one, like let's say it's oranges, if you put two oranges next to each other, they're not considered a distinct order. So the same fruit next to each other, same fruit next to another fruit of the exact same type, another fruit of the exact same type, same type. For example, two oranges next to each other, two oranges next to each other. So if that's the case, so then they're not considered, are not considered a distinct order. Okay, so just give me a chance to show you the example. Let's say you've got 3 apples and you've got 2 oranges and you've got 4 lemons. So you add those up, you see there's 9. Those are the fruits. You're going to put them in their spots there. And the question is, how many distinct orders? How many distinct orders can you display them? How many distinct orders or in how many distinct orders, that's really would be better English. In how many distinct orders can you display these fruits? Okay, so there's a special formula, not complicated. And let me show it to you. It is, you'd have the total number of fruits. This is the generic way of explaining it. Total number of fruits factorial over variety, the variety of fruit, variety 1 factorial, times variety 2, variety 2 factorial. That's not supposed to be a question mark. That's supposed to be a factorial, over variety 3, etc., depending on how many varieties there are. 3 factorial, and you keep going until you run out of varieties. So this one is the third one. How does that translate in our case? Well, the total number of fruits are 9, so it's 9 factorial. You've got 3 of variety 1, which is 3, so that turns into 3 factorial. You've got 2 of variety 2, that's 2 factorial. And you've got 4 of variety 3, and that's 4 factorial. This key thing that you're looking for is how many distinct orders. And there's a couple, there's a total of 9 spots, but they're comprised of repetition, so to speak. There's more than one apple, there's more than one orange, so each variety has to be represented in the denominator, and the total has to be represented in the numerator. Okay, we might be able to work out this number. I'm not worried about a calculator. You can take out your own calculator, but this would turn into 9 times 8 times 7 times 6 times 5. You reach 4 and stop. The 3 factorial would be 3 times 2 and stop. The 2 factorial would be another 2 and stop. What does 3 times 2 equal to? 3 times 2 is 6. So those 2's would cancel out. This 2 would cancel out with the 8. And those are the numbers you'd be left. It's still a significant amount of number. Whatever that number is, use your calculator, etc. But that's how to deal with such a problem. So I definitely wanted to show you that type of problem. Let me show you another one involving combinations to add to our knowledge about combinations here. And we've had this already, but I want to show you another example. Okay, here we go. Problem number 2 on this video at least. And that is as follows. And you've seen something like this before, but let's do another one. Let's say you have 8 apples. Make it 8 oranges. And you've seen that sign before, 5 apples. Okay. How many ways, here's the question, how many ways can you choose how many ways can you choose 2 apples, 5 oranges? And here's how you do it. Is order important? You're choosing 2 apples. Who cares if I care? Apple number 1, they're basically the exact same thing. Apple number 1 coming first, apple number 2 coming second, or vice versa. Who cares? The oranges and the order is not important. So we're dealing with a combination situation over here. If we're dealing with a combination, how many ways can you choose 2 apples, 5 oranges? So let's take the apples first. There's 5 apples that you can choose from. That's our n. We're choosing 2 apples. That's the combination. There are 8 oranges that you can choose from. There's 5 oranges that we're going to actually choose. That's a combination. They're orders. And we want to know how many ways you can do all of this. So we talked about this in a previous video. You don't want to put a plus in between, but the multiplication principle shows up, and you put a multiplication sign in between. So if we worked out the numbers, and again, I'm not committed to get the exact answer, but here is the formula for CNR. It is n factorial over r factorial over n minus r factorial. We'll see how complicated this is without using a calculator right now. That would be 5 factorial over 2 factorial, and 5 minus 2 is 3 factorial. Okay, it looks very manageable. Let's see about this one. This would be 8 factorial over 5 factorial, and 8 minus 5 is another 3 factorial. Where does that get us? So these two 5 factorials cancel each other out. That makes life a little easier. Okay, let's take 8 and the 3 factorial, and what do we get? We get 8 times 7 times 6 times 5 times 4. We reach 3 and we stop. Don't take it. We've got a 2 factorial, which turns into 2, and a 3 factorial, which turns into 3 times 2. We can do some cross out. 3 times 2 goes with a 6. The 2 goes with the 8, becomes a 4. And now this becomes 28 times 20, which is pretty easy 28 times 20 is 560, if I'm not mistaken, and that is the final answer. Okay, so that is the story with that, and those are the two problems I wanted to. One of them we really had before, but I wanted to put that on a video to go over that, plus the new thing that we learned in problem number 1. So I'm going to stop this video, and at this point right here.